Hello, everyone. Thanks for joining us. My name is Adrian. I'm from Guatemala. Currently, I'm a GDE for Android, Firebase, and IoT. And I'm going to be one of your tour guides for the next 30 minutes.
And hi, my name is Cecilia Castillo. I'm also a mobile developer. I work right now mostly on iOS, and I'm going to be your second person on this tour. So first, we're going to start with a little disclaimer. Even though we're going to talk a little bit about how you can leverage learning both languages to have a cross-platform team, I know that each team has its own constraints and processes that they need to follow. So you need to experiment until you find the right workflow that works for you. So let's see what we have for today.
Basically, what we're trying to say is there's no silver bullet, and although both Kotlin and Swift are great languages and modern tools, and we're going to share a little bit about our experience using both. At the end of the day, take this with a grain of salt and decide on yourself what's going to work for you. A little bit of an agenda for the next 30 or 40 minutes. We're going to share a little bit of our motivation behind this talk, an experiment that we designed and built. It's a real simple app to find if it was possible to code something, let's say an app on both iOS and Android, a native app, with some similarities using both Kotlin and Swift. Then we're going to share these findings, and at the end we're going to share a couple of conclusions. So let's get into our DeLorean and travel at 88 miles per hour. I just shared this same slide at a different talk in Guatemala with a group of high schoolers. It's funny because this kind of reveals your age, mostly because for them it was like a nice car, but that was it. Anyway, we're time traveling to 2009. I used to be the co-founder of a development studio in Guatemala. We were the first one doing mobile at the time. One of my co-founders chose the iOS path, I chose the Android path, and we started working on several of our several projects. We started with a product, but ended up doing development for third-party clients. And when you're an entrepreneur, some days you're busy like brooming and mopping the floor, and the next day you're speaking with clients. So at that time, I noticed that all of them wanted several platforms, several mobile platforms. Remember, this is 2009, 2010. So they were asking for Android, iOS, and BlackBerry. Yeah, and besides that, it was a time where iOS was first. So I noticed that they wanted like the three platforms, but they didn't have the budget for all the platforms. So we ended up on the business side, kind of bargaining, offering several platforms with a better offer, let's say, for them to decide on us as the provider of the development. But also I noticed that for our own developers, it was a struggle to work with more than one platform. So I've been dealing with cross-platform apps for a while, and at that time we decided on working with something, a solution that I'm not completely proud about this, but we went with a solution that's cross-platform, and we ended up doing a lot of Cordova apps, phone app, at that moment. After that, I learned my lesson, and I've been a big native advocate since then.
So since we're traveling a little bit back in time, I started working on a company where I was an Android developer, and there was one person that used to tell me a lot, like, even though you're not working on iOS, both solutions should be the same, because at the end, the business requirements were the same. But for me, it was pretty distant, because we usually had different implementation details in each platform. So sometimes the iOS team came up with me and told me, like, this is how I'm doing it, and for me, it was like, okay, this is totally different from what I'm doing, and it was pretty distant for me. But this person was convinced that really, at the end, there were just little details if you look at the big picture. So at one moment in time, I asked this person if I could move from team. So I moved to the iOS team. And I started doing a little bit more work there in iOS. So at first, it was a little hard for me because I was coming from an object-oriented world, and when you transition to iOS, you start looking at protocols, protocol-oriented programming, functional programming, and I wasn't even using Java 8 at the time. So that was kind of like a little difficult at first. But after a while, and after a few years practically, I really got to the point where I actually saw that being able to see both platforms side by side, they're the same. They're just little details that each platform has different. And leveraging on that, I'm able to collaborate more with each team. So that's part of also why I wanted to give this talk. So throughout all of our mobile experience, we have seen how mobile has been evolving. At first, we didn't want to use Kotlin because they didn't have the seal of approval of Google, but then in 2017, I think, Google said, okay, Kotlin is gonna be a first-class citizen in our whole architecture. So we decided like, okay, yeah, let's get into this, let's try Kotlin, and maybe let's try to see if we can collaborate more. So since we are very curious people, we designed an experiment. We wanted to see if, like, learning Kotlin, learning Swift, we could do something fun. So first we wanted to find our ingredients, so what could go wrong? And when we started to ask ourselves with Adrian, like, what could we build, what we could do in order to test this hypothesis, we decided that we wanted to create something that was very simple and sweet. We didn't want to create kind of like a big application that was hard to understand and hard to explain. So we decided to go something very simple. Also, something that we wanted to do is go out of our comfort zone, since in the day-to-day, when you have a code base that's legacy or that it's kind of like a big code base, it's sometimes difficult to try to test new technologies because you have to come up with a plan in order to adopt it. So we wanted to go out of our comfort zone, so we kind of like switch a little bit in the platforms. And we wanted to have something to share afterwards. So that was kind of like our main idea.
Usually, it's difficult to start, and we had a couple of constraints. As Cici mentioned, it was supposed to be something really simple, like a kind of a hackathon project, but also we decided to switch platforms. She's been doing iOS for a while, like a couple of years, and for this experiment, she was going to code her first Kotlin app in Android. And although I got some Swift experience, it's mostly Android I've worked for several years. So we decided to switch platforms for to have some like a different perspective on the app that we were building. And also, as I mentioned, starting is hard. So we didn't have like a clear idea, but when you're deciding what to build, at least we had the idea that we want to build something much like when we're playing Jenga, chose the right pieces to move. And I think as software developers, lots of the times that we're building something new, or at least many of them, we want to build something like this, like in a good shape, but unfortunately, almost all of the times, it ended up being like this with a big technical depth. So in order to build something that we like, we went with something related to dogs. Those are my puppies, Seymour Tebaldo Schumpeter and Mats Chester Baron Puffenders. Really simple names for both of them. And with this in mind, we went with a dog API.
So there are a lot of APIs out there. You have superheroes, Star Wars, food, there's lots of them. But we decided to go through the dogs API because it was very simple. We like dogs, and it served to our use case. So the app that we decided to build was a really small game where we displayed the images of different dogs and a breed that we needed to guess. So if the breed is Schipperkeep, we needed to choose the right dog that was a Schipperkeep. The UI is not so polished because at the end it was just kind of like to test our idea. But whenever you choose one, you have kind of like 10 rounds, and then the score is saved on the local data source. And that's kind of like the app that we're doing. And of course, doing this, I fear that I have no idea of breeds, of what breeds are out there.
As you can see, we're not graphic designers, but you get the idea. Anyway, this is the architecture.
Yeah. So first, we also started to speak to each other to try to find out what was the best approach to share code or functionality, or what approach we were gonna take with this app. Let's face it, there's sometimes when you have an iOS team and an Android team that they usually go like, okay, the product manager tells this is the functionality that we want, then the Android team goes and figures out how they're gonna implement it using their architecture, their style, and then you have the iOS developers that are doing the same, and there's not always too much communication and collaboration between teams. So we wanted to change that. We wanted to really talk to each other and say, okay, this is the approach that I'm gonna take, and this is the layers that we're gonna share. So first we decided that the UI is gonna be really specific to the platform. For example, in iOS you have view controllers, IB outlets, IB actions, and table views registering cells, and that was not gonna change, so we decided that that part is gonna be platform specific. For Android also you have fragments, activities, the XML for the layout and binding and all of that, so we were gonna keep the same for Android also. For the lowest layers you have the data service and the remote service. We said at first that we were not gonna share that code, because also on the remote service, for example, in iOS you have certain libraries that you already use. For example, Alamofire, or for Android, maybe you are a fan of using Retrofit. And for the data service, you use on iOS usually Core Data, and on Android SQLite. So they're different things. So we decided that the shared approach was going to be on the middle. Then we continued with the work.
At the end of the design process, we went with MVVM. I think it's it gives us a pretty good idea and quite straightforward on what are the main components of the app. Luckily, we didn't end up like designing a new framework. And that same diagram, specifically with this architectural approach, is the one that we have here in this slide. We have a local data service. Keep in mind that this is a really simple app. So the local data service is just share preferences in Android and user defaults in iOS. Remote service, as Ceci mentioned, Retrofit and Alamofire. Then we have the repository layer. We chose not to add another layer for interactors because the use cases are quite simple for this app. But we do have the view model layer with live data for Android and manual data binding for iOS. And our goal was to share as much code as possible, because it's on each one of the platforms on different languages, but still it looks quite similar. But as you move to the top on this stack, it's going to be very specific for each one of the platforms. We ended up sharing around 80% of the code on the repository, a little bit around 50 on the view model layer, and less than that on the UI layer.
So I'm a big fan of finding similarities and difference between things. So for example, this is an example from us. We both like raspberries and blueberries, but I'm a big fan of raspberries and he's a big fan of blueberries. So we wanted kind of like to apply this same thing to the experiment that we were building. We wanted to find what were the lookalikes in the language, in the architecture, or in everything that we could find. So one of the things that we find, these are very, very simple lookalikes, and that are very easy to see whenever you just try to work on each platform. For example, you have variables, the way you define variables and define the immutability or mutability of the variables. You have let and var on iOS, and you have val and var on Android. And you have optionals. Well, not in Kotlin, they are not optionals, but you have the null safety part in both languages. For example, the control flow, it's pretty similar in the way you define it and in the way you use it. There are some little differences. For example, in iOS, you do not have the when, but still, in general, you can understand how control flow works in each platform. Collections, both of them have higher order functions, so you are able to apply and transform each of the collections in an easy way, applying different operations. For example, here, this is a really simple example where from an array, I'm trying to remove the nulls and then joining them into a string separated by a space. So in iOS, I use flatmap $0 to say, okay, remove all of the nulls, then join it by a separator. And on Kotlin, I have the same thing using array list of, and you define the first name, last name, and then you filter not null. Even though the operators have a different name, you could very easily understand what is happening without many overhead.
Keep in mind that we were aiming for these similarities. And as both Swift and Kotlin are modern languages, these the variables, control flow, collections, and the higher order functions, among many, are kind of the low-hanging fruit because almost any modern language provides these features. However, the syntax looks quite similar in these cases. As we have these examples, we have many other on similarities, such as typecasting.
In typecasting, both languages have operators to determine if something is a specific type or if you want to cast it to a specific type also. So, for example, in the lowest part, it says is. Is helps you determine if something is of a specific type in both languages. It exists in both languages. And on the upper part, you can see the ask question mark to determine, to cast current to a dog. And as you are aware also, you should use the question mark to make sure that you're casting to the right object unless you are 100% sure that it would not fail. So you do the safe cast. And
by the way, many of these slides include both Swift and Kotlin code, and we deliberately interchange the order, mostly because the syntax, it's quite similar. So what we're trying to prove here is that there are a lot of lookalikes between these two languages.
So another thing that's pretty similar is generics. Generics is not something new. It's actually been since 1970. It's been used by different programming languages like Ada, Pascal, C++, Java. So it's not something new, but it's really powerful. And at the end, it's trying to decouple the type from the implementation. It's not like, usually when you write code like that's repeating over time, sometimes you just extract it to a method and then, okay, let's say I'm cleaning up my code. That's not the case of generics, but you're creating functionality that's independent of the type, and that's where the power comes from it. In iOS, for example, we use a lot of these generics in order to reduce the amount of code that we write and to reuse code everywhere. So it's very, very powerful. For example, in iOS, the standard library for Swift is mostly built using generics. So as you can see, it's very, very powerful. This is one example from iOS. Something common that we usually do is registering and deregistering table view cells, also the queuing and queuing, the queuing table view cells. And that tends to be a lot of lines that are really just being repetitive. So by using generics, you're able to simplify it, contain it in one file only, and then whenever you use it in your view controller, you just write one line instead of colluding your file with a lot of text.
But all these samples looks a little bit generic, also the generics. So here we have a couple of more examples in our app. We're getting a URL from the API, and from that URL we grab the breed. And we wanted to randomly select from the 4 different dog breeds that we got from the API, select one, and then use that for the user to guess. So we ended up doing this As I mentioned, we ended up doing this, as you can see on the slide, as I mentioned, our goal was to write code that look quite similar, but we wanted also to be as much idiomatic as possible without losing this. So this is a couple of samples from our repositories where we're grabbing the data from the API and storing on a data structure, and also grabbing the data from the local storage. As you can see, these cases look very similar in both languages, and also we can notice that when we work in these, let's say, business logic layers, it's easier to write code on both Swift and Kotlin that looks similar. But as we were finding these similarities, we also noticed that there were several differences. So we also decided to include these differences, and in my opinion, the differences are more interesting, mostly because it shows us how powerful each language is on different areas. And as the languages are different, so are we. We both like riding roller coasters, but we enjoy the process in a different way. I don't enjoy that much the process of doing a line. Remember, there are long lines in the amusement park for doing these roller coaster rides. And usually Sis is so excited of being there, and she's like, we're going to get in a roller coaster. I get sweaty hands, sometimes I get dizzy, but once I sit on the roller coaster, everything changes. I'm really excited. So let's see how these languages are different between each other. The enums, it's probably the first, again, the first noticeable thing, mostly because in Kotlin we have Java enums that are, let's say, a little bit simple compared with Swift enums that are powerful. In this case, we are storing state for both success or failure, and on each case we're returning either a value or an error. Unfortunately, it's not possible to do this in Kotlin, but we have a way to manage to build the same pattern using something called seal classes. The seal classes allows us to build exactly the same pattern, returning an state and keeping the result in a way that's easier for us to parse in upper layers after, in this case, after we grab the API, after we do the API call and grab the data from it. Besides that, we also have structs.
So in Swift, you can decide whether to use a class or a struct. The structs are kind of like immutable. So whenever you pass a struct, you assign a struct to a variable, you're pretty much copying that struct to that variable. And sometimes there's moments when you are developing that if you forget that, then you might have bugs in terms of your functionality. It happened for us that at one time we decided that structs, it's the thing that we were gonna use in order to pass information from screen to screen. But it actually created a bug that was really hard to detect, and we didn't find out, kind of like, it took us a while to understand that that was really the bug. But structs are really used a lot in Swift. For example, one use case that's pretty usual is whenever you're getting information from APIs, you parse it and you try to store it in a structure or a class. And usually what we use is a struct, since it's immutable. And this decision between using structs and classes is not always trivial, but it's something that's really important.
We don't have structs in Kotlin, but we do have data classes that are quite convenient. I like and enjoy the less verbosity from Kotlin compared to Java. In this case, although we are just representing an object, a dog, for our app, we just need to specify the properties. If you compare even these two, the struct and the data classes, I think that this is one of the features that Kotlin provides, allowing us to do it in less lines of code, and also keeping all the important things for us to build the app.
Yeah, one thing that I was really amazed when I was doing this part of the code was that I was used to the big files of POJOs where you have getters and setters and all of the things that you needed. And when I saw the data class for Kotlin, I really was impressed how simple it was. So I really liked it. And I also hoped that, never mind.
So I usually digress when doing public speaking. I just remember when we used to have like these plain old Java objects. Saying pollo in English, it's funny for me because I'm a native Spanish speaker, and that's chicken. Pollo is chicken, so basically I'm saying, here we have a chicken. Anyway, back to the data classes. So yeah, we have several other differences, including protocols. This one is quite interesting because it allows us to basically work on a different paradigm when building your code.
Yeah. When I started working on iOS, I came, as I mentioned, from an object-oriented world, so this was very, very new for me, and I didn't have kind of like an idea of how to do it. But whenever you start doing iOS, Apple recommends that you do protocol-oriented programming. So protocols in Swift are considered full-fledged types, so you can pass it as a parameter on a function, you can use it as return types. You can define default implementation for the definition of your protocol. For example, here we have the reuse identifier, and we are defining the default implementation that's returning a string describing the name of the class itself. So this example, for example, is used to get the name of the view controller in order to launch the view controller that you want to display. And I really find it really useful because it helps you to have a composition over inheritance, and it allows you to put the exact functionality that you need for the structs, classes, or nodes that you actually need. Instead of having, for example, in Java, I felt like when you do inheritance, you have classes and subclasses. Sometimes your subclasses have functionality that you do not actually need. And with protocols, these problems was solved in a more granular way. So I think protocols are very, very big on iOS, and they're super useful whenever you want to have code that's reusable and that it's easy to understand.
We have a couple of more differences on each one of the languages, but these last three are a bit more specific for Kotlin. The first one that I really like, it's coroutines, mostly because I struggle a lot with Rx. And it's interesting because I've seen and very few things adopted so fast by the community like coroutines. I'm not sure if it was because Rx is quite complex. Even if you consider that allows you to really build something powerful, it's still complex. So for coroutines, the entry barrier is really low. Here we're working with retrofit, and luckily for us, now it supports coroutines natively. So we don't even have to deal with async await by ourselves. It's part of the heavy lifting that the library is doing. In this case, we're grabbing the docs from the API. So when we're working with coroutines, we need suspend functions. And out of curiosity, how many of you are working with coroutines? Quick show of hands. Like 1/3 of the audience. And follow-up question, how many of you are working with coroutines on production? Almost all of the same hands. Thank you. I'm really happy about this, mostly because, as I mentioned, it's more obvious as, let's say, normal human being to understand the code that's, even if it's asynchronous, looks synchronous. If you haven't worked with coroutines before, it's not something new as generics. It's been around for, I don't know, 40, 50 years in the 70s. Basically, it allows you to write asynchronous code, but in a synchronous way, using async and await, those keywords. As I was saying, here we're grabbing the data from the API. And in order to work with coroutines, basically you need a job and a dispatcher. The job is mostly for housekeeping. The dispatcher is handling all the asynchronous code. And we do have threads like behind the curtains, but coroutines, it's a really powerful tool that, as I've said, I'm really happy that the community is adopting at a quite fast pace. Here we're getting the result. As you can see, the code looks in all synchronous, even if we're grabbing some data from an API. Besides coroutines, we have some more tools that are not exactly Kotlin based, but are related to the language. I mean, what I'm trying to say is that these features are not provided by the language itself, but are part of the platforms. In this case, Android. There have been several talks on dependency injection and server location, and I'm sure that Coin is one of the easiest frameworks to adopt when you're dealing with something complex as resolving dependencies. Dependency injection is a concept that usually I've heard this quote that something can be a $1 million name for a 10-cent concept. In this case, dependency injection is like that. And although Coin is not providing DI exactly, it's doing server location, it ends up being something quite similar. So if you have worked with Dagger, I like Dagger, it's powerful, but if you have worked with Dagger, you get a lot of boilerplate, even for a simple app. This is all the code that we need for a model of Coin. We're injecting the view model and a couple of more layers in our architecture. We just need to define the start Coin method in our application class, and then use it. And it even provides the view model out of the box. In this case, we're doing the game view model by injection. And summarizing a little bit of Coin, I think it's a good idea to explore it. There might be several other alternatives in the future. You can stay with Dagger 2 if that suits your purposes. But even if it's not a language thing, I think it provides a lot of value by simplifying things with resolving dependencies. And lastly, we have live data. That's something specifically related to Android. In this case, we handle a state. This state contains several parts of the UI for the game itself. We just need a variable in our view model to handle this state. And we take advantage of the copy method of Kotlin. Basically, we just copy the object and then change one of the properties. In this case, we're doing that for the progress. And on the UI, we observe this change and then grab the data from the state, in this case, to show progress. We can work with this in several ways, but again, even if this is not something exactly Kotlin related, it provides a lot of value for developers. In this case, we're writing a little bit of logic to display the UI, but basically, I think you get the idea that live data, it's useful, it's powerful when you're doing MVVM. And lastly, we're covering a lot of ground here and have like 5 minutes to go, but we discussed a little bit on this slide. We just want to at least mention how memory management is different on each one of the platforms. Kotlin works with the garbage collector using concurrent mark sweep, and iOS works with automatic reference counting. In a nutshell, with CMS, especially with mark sweep, you need to hold everything for a second, like stop the whole world and mark everything before sweeping. And that might come with a cost at some point. And with ARC, you need to be really aware of what's a strong and weak reference. For someone shifting from Android to iOS, that might come with a couple of drawbacks, mostly because we're not used to do this in Android. Maybe with a sync task, but hopefully no one is using a sync task nowadays. But yeah, memory management is different. There are many interesting details if you are into low-level patterns, like how memory is managed, but this is all that we want to mention at this point. So we have like a minute to go, 5 minutes. The end result for us is that experiments are fun. Of course, we didn't have a budget or a deadline or basically no major constraints, but still, we recommend doing small experiments if possible. Of course, not to do this on production, but we think experiments are a good way of learning what would work for your app. And also, 10 years afterwards, cross-platform is still a challenge. In this case, we were advocating for a bilingual approach, and becoming bilingual, learning Swift if you are an Android developer or the other way around, eventually allows us to have a broader perspective. And this is interesting how it works. I really like anthropology. I've been reading a little bit on this, and currently I think that mostly language and in a minor way food defines our culture. So even for natural languages, it's interesting how becoming bilingual changed your whole mindset. And it's similar when you become bilingual, doing code maybe not in a day-to-day basis, but at least often on a couple of languages that are similar, like in this case are Kotlin and Swift.
So becoming bilingual requires some level of commitment and trade-offs to reduce the overhead from moving from one platform to another one. As I mentioned, there are times when teams have specific code styles, architecture, processes that they want to keep, and unless they're willing to communicate and to have a trade-off in one of these scenarios, it's going to be really a little bit harder for one developer to move from one platform to another one. The idea is to have developers that are kind of like liquid resources. So in case, for example, there's some technical debt that you need to solve in Android, and you do not have like more people to hire, or you do not have any more people on the team that could manage that technical debt, but there are iOS developers that's available, then the idea is that you are able to move one person from the iOS development team to the Android and just help resolve the technical debt, because they have the knowledge of the language, they have the knowledge of the architecture, since it should be a little bit shared, and the style shouldn't be kind of like that different. Even if there's a lot of differences in these areas, you can still be able to move one developer to another one, but you have to be able to pay the context switch time, because it does take a little bit of time to be able to move from one platform to another one if there are too many differences. So that's one really important thing when you're trying to become bilingual. But what it does help is that you're able to communicate more, create a more communication between teams, and you could also help detect bugs, because you actually know how Android works, you know what's the life cycle or where to look exactly for the implementation. There has happened a lot of times in my team where we are developing something and the product requirement is the same, but when we see the implementation, it tends to differ a lot in each platform, and just by knowing like this should have been done in a different lifecycle method, and that solves the problem. And unless you have that knowledge of the other platform, then it's very hard to determine where the bug is.
Eventually, becoming bilingual and understanding the languages on each platform when doing native development can help to see things in a different way and even reduce implementation bugs. Because even if the two languages look very similar, there are some drawbacks on each one of the platforms. So it's a good idea to understand not only the language, the syntax itself, but all the context surrounding each one of the languages and platforms to identify these kind of bugs that could be a little bit difficult. And if you want to go further on this topic, there are transpilers on both ways, like going from Kotlin to Swift or the other way around. I don't recommend this that much, mostly because, to my knowledge, all of the transpilers available have some implementation that's not complete. I mean, you can't have all of the features of one language on the other one, and you lose a lot of the idiomatic approaches when using transpilers. There's also Flutter. There are many other cross-platform frameworks. I think Flutter is going on a nice way, and although it requires some shifting, especially when building UI, because it's a declarative UI, I think it's a good idea to at least explore it. And of course, it's Kotlin native. There's Kotlin native, and it's going at a good pace, improving and adding some more libraries and adding more support to more things. So I think it's worth exploring if you don't want to exactly work with two different teams. And basically, these are our ideas on going further in this topic. And we have like less than a minute, like -1. And we're aware that we're the only thing between you and the party, so maybe 1 or 2 questions? Anyone would like to ask a question? No? We're going to be around today at the party and also tomorrow, so feel free to approach us and discuss a little bit on Kotlin and Swift. Thank you very much.